Hello friends, today we are going to see how to simplify CFGs. Myself Poonam Bharat Kulkarni, I am working as assistant professor in computer department from the ATS SBJ Mirrors. Now first, this topic is related with the two subjects. We can see that automata theory and theory of computation. Firstly, we will see what is the CFG. CFG is actually context-free grammar. So there are many types of grammars, that is regular grammar, CFG is there, next regularly REL is there. So we will see how to simplify the CFG. Now there are three ways to simplify or clean a CFG. Now the first step is the cleaning. Now it contains eliminating useless symbols. Next you have to simplify the CFG. Next, that is the eliminating epsilon productions, or you can say null productions. The third step is the eliminating the unit production. So you can see here there are some production in the grammar. Actually the grammar contains that is VTPS. V means variable, T means set of terminals, P means set of productions, and S is the starting symbol. So in this case you can see here that is A derives to epsilon. So epsilon is the null production and the A derives to B, that is unit production. So to simplify the CFG, first you have to eliminate useless symbols. The next step you have to eliminate the epsilon or the null productions, and the last step is you have to eliminate the unit productions. So first we will see eliminating useless symbols. Now this symbol X is reachable if there exists the production such that S derives alpha into beta. Okay, S is the starting symbol here, alpha and the beta are the terminal symbols. Now next is what? A symbol X is generating if there exists the production X derives W. Now for some W which belongs to T, here T is the terminal symbol. That means W is the terminal symbol. So firstly we have to identify the useless symbols. Useless symbols means which are not reaching to the terminal symbol or which are not generating to the terminal symbol. So the next step is for a symbol X to be useful, it has to be both reachable and generating. So these two productions are very much important in your grammar. S derives to alpha into beta, which is W, and for some W, W belongs to terminal symbols. Now next we have to find out useless symbols. How can we identify that? There is one algorithm, that is it contains some steps. The first step is the eliminate all symbols that are not generating, and next eliminate all symbols that are not reachable. Now is the order of these steps important or can we switch? So this order is very much important. First we have to find out the useless symbol. Now consider a grammar which contains the starting symbol S, which derives to capital A, capital B or small a. Now capital A and capital B are the two variables and small a is the terminal. Again small b is the another terminal. Next, A and S are generating. We can see that A and S are generating. Now for this we can actually draw the tree diagram and we can see that S is reaching to the terminal symbol. Also A is reaching to the terminal symbol. But we can see here B is not generating any terminal symbol, so it is useless. So for eliminating B, we have to remove all productions that involve B. So we have to remove S derives capital A and capital B. So after elimination, your grammar will be just like this. The first S derives small a and capital A derives small b. Now A is not reachable and therefore it is useless. So for the simplified G contains only S derives A. Okay. Now we can think about that. What would happen if we reverse the order, or that is the first test reachability before generating. Now we will fail to remove the A derives to epsilon. Next, algorithm to find all generating symbols. Now the given grammar, that is G is equal to VTPS. What is the basis? Every symbol in T is obviously generating, that is terminal symbol. Next, suppose for a production A derives A derives alpha, where alpha is generating. Then capital A is also generating. Now, next algorithm to find all reachable symbols. Now, the consider G is equal to VTPS. S is obviously reachable from itself because S is the starting symbol. Suppose for a production, capital A derives alpha 1, alpha 2 up to alpha k, where k is reachable. Then all symbols on the right hand side, that is alpha 1, alpha 2, alpha k, are also reachable. Next is eliminating epsilon production. Epsilon means null production. That is the first step. It is not possible to eliminate null productions for languages which include epsilon in their word set. Okay, if we are taking epsilon in the word set, then we cannot remove the epsilon because it will not contain any grammar. After the output, we will not have any CFG. So, what is the definition? A is nullable if A derives to epsilon. Now, if A is nullable, then any production of the form B derives to CAD can be simulated by B derives to CD or CAD. This can allow us to remove epsilon production or epsilon transitions from capital A. So you can see here, if A is nullable, capital A is nullable, then we can only use B derives to CD. Okay, and we can remove capital A. Now algorithm to detect all nullable variables. So there are some steps to find out the nullable variables. If A derives to epsilon, if the production is in G, then A is nullable. Note that A can still have other productions. Okay. Now if there is a production capital B, C1, C2 up to Ck, where every Ci is nullable, then B is also nullable. So you can see that any variable which is deriving another variable, if that variable is nullable, then your B is also nullable. Next, how can we eliminate null production? Now given VTPS algorithm, detect all nullable variables in G. Then construct another grammar which contains, that is G1 is equal to VTP1 comma S as follows. First, for each production of the form A derives to capital X1, capital X2 up to Xk, where K is greater than or equal to 1, Then suppose M out of the K, S are nullable symbols. Now then G1 will have 2 raised to M versions of for this production. Now alternatively, if a production is of the form A derives epsilon, then remove it. Okay. Okay, what does this mean? This algorithm contains some steps. The first step, you have to find out the nullable. That is, you have to find out the epsilon symbol and then you can remove it. Now you can see the example. Consider the grammar which contains the three productions, that is S derives to capital A derives to A capital A and epsilon, B derives to small b capital B and epsilon. So you can see here there are two null productions, that is A derives to epsilon and B derives to epsilon. So first construct the G1 which is the grammar having the L. L means language minus epsilon, that is you have to remove the null. Nullable symbols are what? There are two nullable symbols, capital A and capital B. Now G1 can be constructed from G as follows. You have to consider this capital B derives to small b. Now you have to replace each and every variable in the capital B, that is small b, capital B and B with the epsilon, and you can have this production, that is capital B derives to small b or small b capital B or small b capital B. Okay. Similarly, capital A is also derived by putting epsilon for each and every symbol on the right hand side. So capital A derives to small a or small a capital A and the small a capital A. So you can see here you have to replace each and every symbol from the right hand side with the epsilon. So you can generate the grammar which is null free or epsilon free. Similarly, S derives to capital A, capital B and capital AB. So your final output is here. You can see here the square. In that square, there is a grammar which is final output. Okay, so this is the simplified grammar without null. Now the eliminating unit production. What is meant by unit production? You can see here A derives to capital B. B has to be variable here. B should not be here terminal. Okay, how we can identify the unit production? Then both should be the variables. From the left hand side and from the right hand side there should be variable. What's the point of removing unit production? So you can see here. Now this is the example before conversion, and after conversion you can see that there are many substitutions. Now we will see step by step how we can eliminate unit production. Then unit production is one which is of the form capital A derives to capital B. We have already seen that there must be two variables. From both A and B must be variables. Now consider the example. This is the grammar which contains the four productions. How to eliminate unit production? Now first we have to identify which are the unit productions. Here capital E derives to capital T. Next capital T derives to capital F. Next capital F derives to capital I. These are the unit productions. Next, replace. For elimination you have to replace E derives to capital T with E derives to F or T star F. Okay, you can see here. What is T here? T is another variable and which is deriving to another variable, that is capital F. So you can replace that with the F or T star F. Now we can see that there is another unit production, that is E derives to capital F. So again we have to replace that F with capital I. Okay, you can see here the third production, F derives to capital I. So you can replace F with the capital I. Now in the last you have to replace that capital I with the any terminal symbol, that is capital small a, small b, or 0 or 1. So you can see here step by step we have eliminated the capital T from this production. E derives to T. You have eliminated that capital T. So this E has no unit production. Similarly, eliminate for the remainder of the unit production. Similarly, you have to replace with the T derives to capital F and F derives to capital I. Okay. So this is the summary how to remove the unit production. First, you have to find out the capital A variables are there. If the both symbols are the variables, then that is the unit production, and you can replace that with the terminal symbol. So the unit pair algorithm. Now unit pair algorithm means find all unit pairs in capital G, and for each unit pair you can have a terminal symbol. For example, you can see here there is a unit pair capital A, capital B in G. So add to P1 a new production, that is A derives to alpha for every B derives to alpha, which is a non-unit production. So you can see that this is the diagrammatic representation how we can remove the unit production. So this is the grammar, and these are the unit pairs which is in the tabular form. You can see that, and it is conversion to non-unit production which are added to P1, that is your resultant. So the first, you can see that there is a E derives to T and E plus T. So only E plus T is added to P1. For the next step, you can see that capital T derives to T star F. So this is only added to P1. Next, capital E in the bracket, capital E you have to add into P1. So these are the various steps. So this is the resultant grammar, that is G1. You can see that there is no unit production in this output grammar. Now putting all this together, now if capital G is a CFG for a language that contains at least one string other than epsilon, there is another CFG G1 such that you can see here LG1 is equal to what? LG minus epsilon, and the G1 has no epsilon production, no unit production, and no useless symbol. So firstly, very much important, you have to remember the algorithm. Step 1, eliminate epsilon production. Next step is the eliminate unit production, and the last step is the eliminate useless symbol. So thank you. So this is all about the simplification of the CFG. I hope you have understood with the example and the diagram. So thank you so much for watching my video, and if you like this, then you can like, share and subscribe. Thank you.